Hello and welcome students. This is Indefinite Integration, lecture number 23. Lecture number 23. In last lecture, we studied integration by method of partial fraction. I explained you the details of method of partial fraction and we also took few problems. So let us continue solving few more problems. So here I shall solve question number 19 from the textbook which I am following. The number is not important for you. The exercise is 3.4 from the textbook which I am following. The exercise is 3.4. But what is important for us, numbers and exercise is not important. What is important is the type. So the type here is, see, I have to evaluate or I have to integrate 1 upon 2 sine x plus sine 2x dx. 1 upon 2 sine x plus sine 2x dx. So see here, how do I integrate? This is a very important problem. I write this as 1 upon 2 sine x, and sine 2x I can write 2 sine x cos x. Sine 2x I can write 2 sine x cos x. Now I will take 2 sine x common. So when I take 2 sine x common, I get 1 plus cos x and dx. I get 1 plus cos x dx. Now after this, the step which I do after this, this step here, this step which I'm going to write, this step is very, very, very important. If this step strikes you, if this one strikes you, you get the answer. And if it doesn't strike you, sorry, you can't do it. So what is that step? Everybody watch it now. See, it is I equals to, it is integral. And what I do is I multiply sin x up. It is sin x dx. It is 1 dx. The numerator is 1 dx. I multiply sin x up. Now, if I multiply sin x up, I will have to multiply sin x even in the denominator. So it is 2 sine square x. And here I have 1 plus cos x. Then the next step is I write here, therefore I equals to sin x dx and 2 sine square x. I write this as 2 sine square x. I write 1 minus cos square x. For sine square x, what I write? I write 1 minus cos square x. And this is 1 plus cos x. So the actual aim was, my aim was to make this sin x sine square x. This sin x in the denominator, I wanted to have sine square x. Why? Because if I get sine square x, I'll be able to write 1 minus cos square x. And then you know what? This 1, I can treat it as 1 square. So now this is a square minus b square. So I have I equals to sin x dx divided by 2, 1 minus cos x into 1 plus cos x, 1 minus cos x into 1 plus cos x, and this is 1 plus cos x. What is a square minus b square equals to? A square minus b square is a square minus b square is a minus b, a plus b. So I get this. So next step I get is I equals to, I get here sin x dx and 2 1 minus cos x, and this becomes 1 plus cos x the whole square. In the denominator, I get 2, 1 minus cos x into 1 plus cos x. The next step is I put cos x as t. I put cos x as t. Now, so when I put cos x as t, this cos x I'll be writing t, and this cos x also I'll be writing t. Okay. So as you all know, students, whenever you go for a substitution, what happens is the integral changes. Okay. You write the new integral in new variable. You write the new integral in new variable. So here I write put cos x equals to t. Put cos x equals to t. Then I differentiate with respect to x. So d by dx of cos x is minus sin x equals to d by dx of t. So you can check, you all can check here. Cos x I'll be writing t, and for sin x dx I'll be writing minus dt. What I'll be writing for sin x dx, you can check here. See, this dx I multiply with sin x. So sin x dx, I'll be writing minus dt. So the new integral which I will get, it will be, so the new integral I will get, therefore I equals to what I was sin x dx in the numerator, that I will write minus dt, and denominator it is 2 multiplied with 1 minus t, 1 plus t square. 2 into 1 minus t and 1 plus t the whole square. So the next step, I can write 1 upon 2 out. I can write 1 upon 2 out. And here I have negative 1. See, this negative dt is nothing but minus 1 dt. Now this minus 1, I have options. Like if I want, I can take this minus 1 outside, because minus 1 is a constant. So, you know, if I do that, I will get minus half here. This is one option I can do. Or what I can do is I can take this negative sign in the denominator, and see, if I take the negative sign in the denominator, what happens? This 1 minus t will become t minus 1. The sign, you know, the sign changes. Negative t become positive, the positive 1 become negative. So I have t minus 1, and the numerator I have only 1 dt, because that negative I took down. And here I have 1 plus t square, which I would like to write t plus 1 the whole square. So now this is my integrand, which I find ready for applying method of partial fraction. Here I find it ready for applying the method of partial fraction. Why do I find it ready here? See, because I understand that first of all, it is a rational fraction. It is a rational fraction. In the denominator, you just check. In the denominator, if I multiply these two brackets, it will get me a polynomial in the denominator. And the numerator is 1. Okay. So I can call 1 as a polynomial with degree 0. So I have numerator and denominator both polynomials. So it is a rational fraction. Moreover, I understand that it is a proper rational fraction. Okay. So here I find the integrand ready for applying the method of partial fraction. Okay. So I'm going to apply the method of partial fraction. For those who do not remember what partial fraction was, I will help you out by saying what partial fraction was. In partial fraction, what we did was, when we had a fraction, where the denominator had number of factors, we wrote one fraction as sum or difference of two or more than two fractions, depending on how many factors we have. So one single fraction, you can write it as sum of two or more fractions, then the method is known as partial fraction. Okay, so here what I'll be doing, I'll be applying the method of partial fraction. Very good. Now I want you all to note something here. Now this note I'm writing for you. This note is for the sake of learning. You don't have to write this in your exam when you are writing the solution. See, the note here I'm writing is this. I find it is the second type of partial fraction problem. It is not the first type. It is the second type. Why second type? Because here I notice the denominator contains the denominator contains repeated linear factors. See, why repeated linear factors? Where do I see repeated linear factors? See, I see it here. T plus 1 the whole square. You can check. When you have t plus 1 the whole square, it means the denominator is actually in the form t minus 1, t plus 1 and t plus 1. So see, it is denominator has t plus 1, which are linear factors, but they are repeated. T plus 1 is 2 times. So we call it as linear repeated factors. What we call it as linear repeated factors. Okay. So let us solve this problem. I have already taken in previous lecture, that is in lecture number 20, in lecture number 22, I had taught you how do you resolve a fraction into two or more fraction when you have linear distinct factors. The type 1 was where the denominator had linear distinct factors. That is, in the denominator you see all factors different from each other. The factors are not repeated. That was type 1. This is type 2. Okay, so see, how do I do it? I will write let, and I take this thing out. I take this out here because I want to work on it. So let 1 upon t minus 1 into t plus 1 square equal to, okay, what I will write? I will write this as a upon t minus 1 plus b upon t plus 1 plus c upon t plus 1 square. This is important. Learn it. A upon t minus 1 plus b upon t plus 1 plus c upon t plus 1 square. This is to be learned. Okay. If I had now, let me make some change. Suppose I had here 1 upon t minus 1, t plus 1 and t plus 2. In this case, what would have I done? In this case, I would have written 1 upon t minus 1 plus 1 upon t plus 1 plus 1 upon t plus 2. This is what I would have written. I'm sorry, a upon, b upon and c upon. Okay, I'm sorry. What would have I done? I would have assumed, okay, I would have assumed the constant to be a, b and c, and then Under A, I write one factor. Under 2, I write this. Under A, I write this. Under B, I write this. And under C, in the denominator of C, I write t plus 2. Okay. And what type it is? It is the type when the denominator has linear distinct factors. Okay. But here, see, it is linear repeated factors. Now, since you have t minus 1, t plus 1 square, you will still have A, B, and C. Okay. A will have t minus 1 in the denominator, B will have t plus 1, and C will have t plus 1 square. That is by rule, you should understand. Okay, this is how it is. If you do not follow this technique, you will go wrong. Okay, so here it is. Now, suppose here I had 1 upon t plus 1 cube. In that case, what would have I done? What I'm saying is, if you have 1 upon t minus 1 t plus 1 cube. Now see, if it is cube, then you will go as follows. You will write a upon t minus 1. Then you will write b upon t plus 1. Then c upon t plus 1 square. And d upon t plus 1 cube. Try to follow this. Here you had t plus 1 cube. Okay, so t minus 1 is a separate factor, so it will come under A in the denominator of A. Now for t plus 1 cube, you will start with the fraction, the first fraction where the denominator has t plus 1. Then you will gradually increase the power of t plus 1 in the denominator. The next has t plus 1 square, and the next has t plus 1 cube. And this is how it will. There will be 4 constants which you will take help of. A, B, and A, B, C, D. Here there are 3 constants. So I hope you must have understood. So the number of constants are depending on how many total factors you have. So as such, if you see, it is t minus 1, t plus 1 into t plus 1. It is t plus 1 square. So t plus 1 square actually, it gives us t plus 1 square actually gives us t plus 1 into t plus 1. So in total, there are 3 factors in the denominator. So you will get 3 fractions. Only thing you have to take care of is, don't write b upon t plus 1 and again c upon t plus 1. Please don't write b upon t plus 1 and c upon t plus 1. No, it is b upon t plus 1 and c upon t plus 1 square. The power will increase. The power will increase. I hope you must have understood this. Let's go ahead now. The next thing what I do is, now I take LCM. I take LCM here. So LCM here will be, you can check, the LCM here will be LCM of the denominator. So it is t minus 1 and t plus 1 square. This is LCM of these 3 factors. Okay. So what do I get with A? See, with A, I will get A into t plus 1 square. Okay, because the LCM is t minus 1, t plus 1 square. T minus 1 cancels. I'm left with only t plus 1 square. So that is LCM. Now that is to be multiplied with, this is LCM. So when I divide this by t minus 1, what happens? I get only t plus 1 square. I get only t plus 1 square. Okay, and that t plus 1 square will multiply the numerator, which is A. So A into t plus 1 square. Now here I have B. See, when I divide this, when I divide the LCM by denominator of B, so this is divided by t plus 1. So what do I get? I get t minus 1 into t plus 1, which multiplies B. Okay, that multiplies B. So here I get, what do I get? I get here B multiplied with t minus 1 into t plus 1. And here C has denominator t plus 1 square. LCM is this. When I divide the LCM by its denominator, I get t plus 1 square cancelled. So I get c into t minus 1. T minus 1 I get. And what is the denominator here? Denominator here is t minus 1 into t plus 1 square. And here you have 1. What happens next is this cancels. So I get here I equals to, sorry, therefore 1 equals to a multiplied with t plus 1 square plus b multiplied with t minus 1 into t plus 1 plus c multiplied with t minus 1. And this is equation number 2 because this is 1. Now, as I have been telling you, this equation number 2 is an identity. Remember students, this equation is an identity. What does that mean? It means this equation is true for all values of t. It is true for all the values of t. So you know what I will do? I will put t equals to 1 there. I will put t equals to 1. So when I put t as 1, what will happen, you know? If I put t as 1, this will become 0 and this will become 0. When I put t as 1, I get t minus 1 as 0, and 0 multiplied with b and c, they will be eliminated and I will get the value of a. So that is my trick. Okay. So in last lecture, I had taught you, if you remember, that if you want to get value of a, then you should put the value of, if you want to get the value of a, then you should find out the denominator of a and make it 0. So t minus 1, 0, t is equal to 1. That's my technique. Okay, so here I write, see I write here, put t equals to 1, t equals to 1 into. So I get therefore 1 equals to a into t plus 1 square, that is 2 square, and here b multiplied with 0, because when you are putting t as 1, this goes 0, and c into 0. So what is the final answer that you get? You get therefore a into 4 equals to 1. You get here 1 equals to a multiplied with 4. So this gets you a value as 1 upon 4. A is 1 upon 4. I got the value of a. Similarly, I will get the value of b. For b, what I do is I put t as minus 1. Okay, because I want to make the denominator of b 0. So if I make the denominator of b 0, I'll get the value of b. So I write here put t equals to minus 1 in 2. Okay, in 2. So I get 1 equals to a into 0, because when you put t as minus 1 plus 1 becomes 0. Okay, and 0 square is 0, a multiplied with 0 is 0. And here, when I put t as minus 1, see what will happen. Minus 1 plus 1, I get 0, b into 0. What I get? I get b into 0. So t minus 1, so a into minus 1 plus 1, 0, plus b. Here see what I get. I get minus 1, minus 2, but here I get minus 1 plus 1, 0. So b into 0, plus this is c, and I get minus 1, minus 1. What I get? Minus 1, minus 1. So here I have 1 equals to c multiplied to negative 2. So c is equal to minus 1 over 2. This is C. I got the value of C as minus 1 over 2. What is C? C is minus 1 over 2. Very good. So now next value I have to select for T. I have to select next value for T by which I get the value of C. Sorry, I get the value of B. I substitute T as 1. I substitute T as 1. I got A. I substitute T as minus 1. I got C. Now which value of T I choose so that I get the value of B? I tell you, see students, T1, T minus 1 have already happened. The next value I will put for T is 0. I will put T equals to 0 in 2. I will put T equals to 0 in 2. You should not worry because since you have already got the value of A and C, whichever T value you will put, it will get you the value of B. So I write here put T equals to 0 in 2. So when you put T as 0, see what you get. You get 1 equals to A. 0 plus 1 square, that is A into 1 plus B. 0 minus 1 is minus 1, 0 plus 1 is plus 1. So it is minus 1 into 1, that is minus 1, plus C, and T0, C into minus 1. This is what you get. Now this value of A and C are already known. See, A and C are already known. So what I will do, I will use them. In place of A, I write 1 by 4 and this is minus 1 by 2. 1 equals to 1 by 4. A is 1 by 4. A into 1 is A. Minus B. And then here I have minus of C. See, I have minus C. C into minus 1 is minus C. So it will be minus of C. But what is C? C is minus 1 by 2. C is minus 1 by 2. So here minus of minus 1 by 2. So you get 1 equals to 1 by 4 plus 1 by 2 minus B. So I take this B to the left. I get B equals to 1 upon 4 plus 2 upon 4. What I did, I multiply up and down 2. So it becomes 2 by 4. Minus 1. This one I'm taking on to the right. So B equals to, you got 3 by 4. You got 3 by 4 minus 1. That is equal to, you have 3 minus 4 upon 4. That is minus 1 by 4. This is B. I got the value of B as minus 1 by 4. Okay. Now, after getting all the three values, you understand what will be the next step. After getting A, B, and C, now what I'll do, I will use A, B, and C in one. Using A, B, and C in equation 1. So what was that equation? If you check, it was the one where you assumed the possibility of three constants A, B, and C such that this fraction could be resolved in more than one fraction. Okay, so equation 1 is a very important equation. So what I will do is now I'll substitute the value of A, B, and C here. So when I substitute, I get 1 upon T minus 1 into T plus 1 square, 1 upon T minus 1 into T plus 1 square equals to, it was A upon T minus 1. Please do not change the order, If it is A upon T minus 1, then you write it properly because T minus 1 has the numerator A. Accordingly, you have solved. So if you change this order, like you write here, you solve this way, but while substituting, if you write A upon T plus 1, then it will go wrong. So A upon T minus 1, what is A? A is 1 by 4. So you have 1 upon 4 upon T minus 1 plus B. What is value of B? B we got b as minus 1 by 4. So we got minus 1 upon 4 and upon t plus 1. See, here it is t plus 1. We are working on this. We are working on this step, this step. So b upon t plus 1. b is minus 1 by 4 upon t plus 1 plus c upon t plus 1 square. And what is c? C is minus half. So I got plus minus half and t plus 1 the whole square. T plus 1 the whole square. Okay. So I have already got the value of a, b and c. This is equation number 3. Now what I will do is, it was this that we wanted to integrate. You can check. The integration was 1 by 2 and integration of this, which I have written using all this. So I write therefore I equals to 1 upon 2, which was outside. You can check. 1 by 2 is outside, and then you have integration of this. What is that equal to? It is 1 upon 4. This 4 will come down. 1 upon 4t minus 1. 1 upon 4t minus 1 minus 1 upon 4 t plus 1 minus 1 upon 2 t plus 1 the whole square. Okay, it's a great achievement, students, because now you can integrate it very easily. So next step, now I write separate integral. So when I write separate integral, I do also multiply 1 by 2 with each one of them. So when I do that, see, I get 1 over 8 1 upon t minus 1 1 over 8 1 upon t minus 1 dt. Then I get minus 1 over 8 integral 1 upon t plus 1 dt. 1 upon t plus 1 dt I get. Okay, and then I have here negative 1 over 4 outside constant. This 2 multiplies with 1 by 2. And here I get 1 upon t plus 1. I get 1 upon t plus 1 the whole square and dt. Okay, we have integration of all of this. This is 1 upon t dt. But t is replaced by linear algebraic in x. 1 upon t dt integration is log of mod t. So this will be 1 upon 8 log of mod of t minus 1 minus 1 upon 8 log of mod of t plus 1 minus 1 upon 8 log of mod of t plus 1. Okay, minus 1 upon 4, and this is the integration of 1 upon t square. What is the integration of 1 upon x square dx? Integration of 1 upon x square dx is minus 1 upon x plus c. So 1 upon t square dt will be minus 1 upon t plus c. But what's happening? It is not t square. In place of t, we have linear algebraic in x. So the result will remain same because we are allowed to replace a variable by linear algebraic in the same variable. Okay, ax plus b. In place of t, x, we can write ax plus b in a function. In place of t, we can write at plus b in a function. So this is what function? 1 upon t square. T is replaced by t plus 1. Okay, so here I have minus 1 upon t plus 1. And since the coefficient of t is 1, no need to divide, because even if you divide, you will end up getting same thing. You will end up getting, okay. So minus 1 upon t, 1 upon t plus 1, and finally plus c. So here I get I equals to, I take 1 over 8 common. 1 over 8 is common. So I get here log t minus 1, log of t minus 1 minus log of t plus 1 plus 1 upon 4 into t plus 1. 1 upon 4 into t plus 1 plus c. And what was t? T was, it was, you check here, t was cos x. So I will substitute for cos x. So here I get, therefore I equals to, what do I get? I get here 1 upon 8 log of cos x minus 1. I have 1 upon 8 log of cos x minus 1 minus log of mod of cos x plus 1. Okay, minus 1 upon 4 cos x plus 1. minus 1 upon 4 times cos x plus 1 plus c. Now this is log m minus log n, log of m by n I get. So here 1 over 8, I get log of cos x minus 1 upon cos x plus 1 minus 1 upon 4 cos x plus 1. Cos x plus 1. This is the final answer plus c. This is the final answer. I hope you all must have understood. In case if you find any difficulty, the best way to know this is you watch this several times and also make note of all this. You must write it. Writing will make you remember this. Okay, just go through the whole solution once again. Yeah, there is a mistake I committed. This is plus, and this is also plus, because here minus and minus we had got plus. Let's have few problems of similar type. So the textbook which I'm referring to, I solved 19th for you. This problem number 18, 20 and 21, they are of similar type. They are of similar type. Here what you will do, you will, as we did for problem number 19, you will apply sine 2x formula and then you will take sine x common, and after that you will have two brackets. So sine x is common, you will multiply sine x up so that down it becomes sine square x, and then sine square x you will write 1 minus cos square x. 1 minus cos square x is 1 square minus cos square x, which is 1 plus cos x, 1 minus cos x, and then what rest to be done you will know as you solve ahead. Similar thing you will do here, sine 2x you will write 2 sine x cos x, and this time you have sine 2x plus cos x. So you will write 2 sine x cos x plus cos x, and this time you will take cos x common. It is cos x which you will take common. So when you take cos x common, you will get two brackets, two factors. One of them is cos x. You will multiply up and down cos x. So you will get cos square x in the denominator. So as in the previous problem, you had sine square x, and for sine square, you wrote 1 minus cos square. Here for cos square, you will write 1 minus sine square. And then, for 1 minus sine square, you will write 1 plus sine x, 1 minus sine x, and then later you will do what is required. As you solve, you will understand it. And similar way here also you have to solve. Now these three problems which we have, one thing is common, that in these three problems, even the problem that we solved, that is for, I'm talking about problem number 19, you had A, B, and C. You get three factors. You get three factors, and that's why you get A, B, and C. Three constants you will have to assume. Okay. Now, when you solve these three problems, like in 19th, you saw that you had repeated linear factors. In 19th, what you saw, that you got the factors, but in the denominator, you had factors repeated. So this is how you go ahead. You went ahead, right? Now, whether here, the problems which I'm giving you, whether you will get repeated linear factors or not, that you will solve and you will know. Okay, very interesting problems these are. Now, along with these, you will also solve question number 13. In 13th question, which I have written, it is you have repeated linear factors. So I can help you out. I can give you one more. I have already solved this, but I will help you out once again here for 13th. So the 13th is you have I equals to 3x minus 2 upon x plus 1 square into x plus 3 dx. So what you have, you have this as The integrand, it's a rational fraction, polynomial of x, polynomial in x in numerator, polynomial of x in denominator. This fraction, which is a single fraction, I would like to write it as several fractions. So here, how many fractions I will get? I notice that in the denominator, I have linear factors, but repeated linear factors, because x plus 1 is repeated. It is x plus 1 into x plus 1. I've got x plus 1 square. So here, as I taught you in the earlier problem also, earlier problem was in trigonometry, but later it got converted into rational fraction. Okay. Here, it is directly a rational fraction. So I will write here, let 3x minus 2 over x plus 1 the whole square into x plus 3 equals to a upon, see here, I have x plus 1 the whole square. So I will begin with x plus 1. Then I will have b upon x plus 1 square. Then I have c upon x plus 3. Okay. Then what I do? I take LCM. What is LCM for this? The LCM would be x plus 1 square into x plus 3. The LCM of these three factors, x plus 1, x plus 1 square, and x plus 3. So what do I get with A? With A, I get, now see, for A, what you need to multiply, you will get when you divide this LCM by the denominator of A. So when you divide this x plus 1 square by x plus 1, you get x plus 1, x plus 3. So here x plus 1, x plus 3, you get x plus 1, x plus 3, plus b into x plus 3, you get b into x plus 3, and here you get c into x plus 1 square. Okay, because when you divide this by x plus 3, the denominator of c, x plus 3 cancels, and you get x plus 1 square, which you multiply with. Okay, then, and here what do you have in the left hand side? You have 3x minus 2 and x plus 1 square into x plus 3. Now you know that these two cancel. These two cancel. So whatever you have, it's only the numerator that you are left with. So you got here 3x minus 2 equals to a multiplied with x plus 1, x plus 3, plus b multiplied with x plus 3, plus c multiplied with x plus 1 the whole square. Now this I write as equation number 1, and this is equation number 2. Okay. Now, as you know that this equation number 2 is an identity. It is an identity. What does that mean? It is true for all values of x. Now, initially what I will do is I will find the value of few of the constants from ABC by elimination. So see, I understand that if I put x as -1, now how do I get the idea of putting x as -1? I look at the denominators of these. So as such, you know, you have only two types of denominators, x plus 1 and x plus 3. So x equals to -1 and x equals to -3 are two apt substitution. They are apt substitution. So I put x as -1. When I put x -1, see what will happen. When I will put x -1, this will become 0. Remember, this will become 0. Now this becoming 0, this a will be eliminated, because 0 into a is gone. And remember, this will also become 0 when I'm putting x as -1. Okay, so putting x as -1, I get the value of b. What do I get? I get the value of b. Okay, because a and c are eliminated. Very good. I get the value of b. Then I will put, see, x plus 1. Now I will put x as -3. So when I put x as -3, see what happens. Here, this goes 0. Now 0 into a is 0, and this goes 0. So 0 into b is 0. So a and b are eliminated, and I get the value of c. I get the value of c. So you should understand that by substituting x as 1, x as -1 and x as -3, by substituting x -1 and x -3, you could find the value of B and C, these two values you could find. Now you are left with value of A. So what you will do, see in this equation, as you know, this equation is true for all the values of X, and B and C have already been obtained. So you can choose X as 0. You can take any value of X. So you take X as 0, and whatever value of B and C you have obtained, using those values along with 0, you can find the value of A. You can find the value of A. So B, C and A, all you got. Then what you will do, after getting the value of A, B and C, you will substitute them here, and then you will integrate. Okay, how do you integrate? That you will know when you do it. Okay, simple results you have to apply. So I hope you must have followed this. I just give you a hint how to solve. So these 4 problems you must try. They are very important problems. They are very, very, very important problems. And remember, students, you practice, you become perfect. In case if you have doubts, you can always write in the comment box. I will give answers. I will make a video on your doubts as well. Here we have one more problem for practice. See, this is integral 12x square minus 2x minus 9 divided by 4x square minus 1 into x plus 3. Now in this problem, what has to be focused upon is this bracket. Many students do not understand. Many students do not understand that this 4x square minus 1 can be further factorized. So 4x square minus 1, I write 2x the whole square minus 1 square. See, this 4x square minus 1, it appears to be a quadratic factor. But remember, though it is a quadratic factor, but this quadratic factor can be further factorized and it will become a linear distinct factor. So this 4x square, I write 2x the whole square minus 1, I write minus 1 square. So 2x square minus 1 square, it will become 2x plus 1, 2x minus 1, and into x plus 3. So now I have denominator having 3 different linear factors, 3 distinct linear factors, that is non-repeating linear factors. So it is type 1 of partial fraction problem. Now some of students have doubt that why are we not referring to numerator, because many a times it is seen that the numerator is a quadratic, like here I have quadratic, but what if the numerator is 2x minus 9 and denominator happens to be same what it is. See, if the denominator is 2x minus 9 and if the numerator is 2x minus 9 and the denominator is same as it is, we are going to apply partial fraction method the way we would have applied had the numerator been with 2x 12x square. See, the numerator doesn't matter. Numerator, what numerator is, it will not make any difference if it is a proper fraction. The only importance of numerator is you have to check whether the degree of numerator is lesser than the degree of denominator or not. Now here I notice 12x square, so the degree of numerator is 2, because the highest power of x is 2. And if these two brackets I multiply, the polynomial which I will end up with, it will have the highest power of x as 3. So degree of denominator is 3. And hence this becomes a proper rational fraction. And remember students, if you have a proper rational fraction, you can apply the method of partial fraction. So the only importance of numerator is to decide whether the given fraction is a proper or an improper fraction. Other than that, there is no importance of numerator. whether it is 12x square or it is without 12x square, it is a quadratic polynomial or it's a linear polynomial, all that simply doesn't matter. So here I wrote 4x square minus 1 as 2x the whole square minus 1. Now 2x the whole square minus 1 is 2x plus 1 into 2x minus 1, and this x plus 3 as it is. So now I have linear distinct factors. So after this, what do we write? After this, as I'm having 3 factors in the denominator, this would give me three different fractions. So what I will do is I will take 12x square minus 2x minus 9 upon 2x plus 1 into 2x minus 1 into x plus 3 equals to a upon 2x plus 1 plus b upon 2x minus 1 plus c upon x plus 3. This is my equation number 1. Now, as we have done in the earlier problems, you will take LCM and then you will take LCM and then you will get an identity. So after taking LCM, the identity that you will get is you will get 12x square minus 2x minus 9 equals to, you will get a multiplied with these two, a multiplied with the denominator of b and c, that is 2x minus 1 into x plus 3, then b multiplied with the denominators of a and c, 2x plus 1 into x plus 3, and c multiplied with the denominator of a and b, 2x plus 1 and 2x minus 1. But remember students, what we did here, that a multiplied with denominator of b, c, b multiplied with the denominator of a, c, and c multiplied with the denominator of a, b, this does not work for the second type of partial fraction method. This works only for the first type. You saw when we had repeated linear factors, this will not work. There you will have to be very careful while writing the second equation. Okay, I wrote directly the second equation because the denominator I considered to be cancelled, as they will cancel. Now what you will do, you will one by one, you will eliminate a, b, and c. Okay, in order to get the value of a, you will eliminate b and c. And how will the b and c be eliminated? You will take x value as negative half. When you put here x value negative half, now how do I decide x to be negative half? Very simple, very simple. I first decide to take the denominator of a to be 0. When denominator of a I try to make 0, I will have to put x as negative half. Now x negative half, you will see you got here 2x plus 1 and you got here 2x plus 1. So what will happen? 2x plus 1 will be 0. So 0 multiplied to b and 0 multiplied to c. B and c are eliminated. You get the value of a. Then you will substitute the value. You will try getting the denominator, what the expression, the factor that you have in the denominator of b, you will try making it as 0. For that, what you will do, you will have to put x as 1 by 2. You'll put x as half. So when you put x as half, what happens? See, you get this 0, you get this 0. So a and c are eliminated. You get the value of b. And similarly, when you put x equals to negative 3, because the expression, the factor in the denominator of c is x plus 3, you will get a and b eliminated. You get the value of c. So this way you get the value of a, b, and c. You substitute a, b, and c here, and then you write final answer. See, when you get the value of a, that constant will write out, and it will be integral 1 upon 2x plus 1. B will go out, you will get integral 2x minus 1, and c will go out, you will get integral x plus 3. Now you know integral 2x plus 1. See, when you will get integration of 1 upon 2x plus 1 dx, after you will have substituted the value of a, b, and c, integration of 1 upon 2x plus 1 will be log of 2x plus 1, the whole divided by 2, because coefficient of x is 2. Okay, so that way you will complete this problem. You must try completing this problem. We will now take another question. Let's take this problem. Here I have integral 2x divided by 2 plus x square into 3 plus x square. Now here what I notice is I have got two factors in the denominator. If I multiply, I will get a polynomial which will have the highest power of x as 4. It will have x power 4 and the numerator x power is 1. So it's a proper rational fraction for sure. And it is, since it is a proper rational fraction, I can apply partial fraction method, for which I have to get the factors. And the thing is, I already have factors. But here what happens is this one is not falling in any pre-mentioned type. That is, we have three different types, as you know. So this is not linear distinct factors. It is the power of x is 2, and here we do not have repeated repeated linear factors. Then we do not have the third type as well, which was a quadratic factor with a linear factor. But one thing very specifically I notice, and that thing strikes me well. See, what is it? I understand that if I put x square as t, see, if I'm putting x square as t, these two, x square here and x square here, these two will become t. I will get their t. Moreover, if I'm planning to have t here, so everything has to be in t, and this dx will have to be changed into dt. So I write differentiating with respect to x. Differentiating with respect to x, so I get here d by dx of x square is 2x, and this is d by dx of t. So I get here 2x dx, as I get here 2x into dx equals to dt. So you can understand, see, this 2x dx will become dt. Now, as you all know, we will write the integral after substitution, the new integral. So the numerator is, the whole numerator is dt, and the denominator is 2 plus t into 3 plus t. So what we have here, so we have here I equals to 1 upon 2 plus t into 3 plus t and dt. Okay, after this, you know the technique. What you will write? You will write this as 1 upon 2 plus t. You will write let. There is a faster method here. That faster method I will tell you, but before that, for those who are following the actual technique, so you write 1 upon 2 plus t into 3 plus t equals to a upon 2 plus t plus b upon 3 plus t, and after that this is 1. You will take LCM. When you take LCM, the denominator is 2 plus t into 3 plus t will cancel with the denominator in the left hand side, and you are left with 1 equals to a multiplied to 3 plus t plus b multiplied to 2 plus t. This is your equation number 2. Then when you substitute t as -3, this is an identity. This equation is an identity. That is, it is true for all values of t. It is true for all the values of t. Now in this equation, when you put t as -3, you get the value of b, because a gets multiplied to 0. T as -3 makes this factor 0. So you get the value of b. When you put t as -2, you get b multiplied with 0. So you get the value of a. And that a and b you substitute here. And then for one single fraction, which was not integrable as it is, you transformed it into two fractions, and then you integrate each one of them. Okay, you know, integrating 1 upon 2 plus t dt is log of 2 plus t dt. That a and b you will have taken outside the integration sign, because a and b will be constants. Okay, so this is how you do it. I have taught. But then here I'm telling you one faster method. Now this faster method works. This faster method will work only when the numerator is 1. Only when the numerator is 1, this faster method will work. If the numerator is a variable, like here, what is the variable? It is t. So suppose if you have something in t, this faster method doesn't work. The faster method will work only when the numerator is 1. So suppose numerator is some other constant, like numerator is 17. Then what you will do? Will the faster method work? Yes, it will work by taking 17 out. Then you will write 17 out and then apply the faster method. Okay. So if it is a constant, like you have say 18, will it work? Yes, because then 18 you will write out and the numerator will become 1. But the problem with variable is, suppose if you have 2t plus 3. Okay. Now if you have 2t plus 3, then only this method will work, because here also you will have 2t plus 3, and then here also you will have 2t plus 3. So only this method will work. Which method? Like writing, assuming the presence of a and b such that we could write this as two fractions, and then taking LCM, then getting one identity, and then eliminating a to get the value of b, eliminating b to get the value of a. All that will work only when you have, all that you will have to do if you have the variable in the numerator. Okay. But here, fortunately, we have 1. So the faster method will work. Now, what is faster method? I shall be writing it here. Please see, the faster method goes as follows. See, in the faster method, what it is. If the numerator is 1, if the numerator is 1, 2 plus t and 3 plus t you have, what you should do is, you should see the difference between these two. You should be able to know the difference between the two fractions. What is the difference between the two fractions? The second fraction is 1 more than the first fraction. Second fraction is 1 more. It is t plus 3, it is t plus 2. So this is 1 more. So see what you will do. You will write 1 upon 2 plus t minus 1 upon 3 plus t, 1 upon 2 plus t minus 1 upon 3 plus t, and into, divide by 1 upon the difference, that is this minus this. So what is this minus this? It is 1. So this is what you will get. See, so you already got it. So what is this equal to? Now, as you know, 1 upon 1 is 1. 1 upon 1 is 1. So this is not there. So what is it? You got the answer. What is this equal to? You have made one fraction into two fractions. See, so fast. It is so fast. Okay. And when you will solve by this method, the one which I said, when you will solve by this method, you will know that a is 1 and b is minus 1. You are getting b as minus 1. That's why you are getting minus here. A and b will be plus 1 and minus 1 respectively. Okay, now I will give you one more example. Suppose I had 1 upon 2 plus t, and this I had here 7 plus t. Then what would have happened? Very simple. See, I would write 1 upon 2 plus t minus 1 upon 7 plus t, I will write. And what's the difference between these two factors? The difference is 5. So I will write 1 upon 5. That's it. I will divide by 5 because this is 5 more than this. So this all you will have to see. You can use the faster method sometimes. If you haven't followed this faster method, I would suggest you stick to what I have taught you. So here you get the value of a and b, and once you get the value of a and b, You will substitute in this and then solve this. I hope you all must have understood this. Okay.